Welcome back, everyone. Ready for another deep dive. Today, we're tackling how our brains learn those series of movements, those motor sequences.
Yeah. Like, think about mastering a dance routine.
Or how about even just learning to tie your shoes?
Right. It's incredible how our brains handle those complex movements. We don't even realize what's going on half the time.
It really is amazing. And today, we're looking at a study called Training-Related Changes in Neural Beta Oscillations associated with implicit and explicit motor sequence learning.
Catchy title, huh?
Well, we'll unpack it all. We're talking implicit versus explicit learning, those cool brain waves called beta oscillations.
And we'll make sure to connect it back to how we can actually learn new things effectively.
You got it all about those practical takeaways. So let's jump right in, shall we? Implicit and explicit learning. The research gives some pretty relatable examples.
Like brewing coffee, picking up a dance routine, or tying your shoes.
Right, everyday stuff. But what's the core difference between those two types of learning?
The big thing is awareness and intention. Think about riding a bike,
Oh, yeah, classic example.
That's implicit learning in action. You can't really explain how you balance. Your body just does it.
My brain's figuring it out without me having to give it step-by-step instructions.
You got it. Unintentional learning happening below the surface. Now, explicit learning, it's different. You're consciously putting in the effort. You can break it down into steps.
So more like learning a new recipe. I'm carefully following those instructions.
Precisely. You can explain that process to someone else.
Okay, so with implicit learning, I'm more like picking it up through experience, maybe observation, but explicit learning is deliberate, focused.
A great way to put it. And traditionally, skill learning was thought to go from this cognitive phase where you're gathering knowledge, explicit learning, to this automated phase.
Where it becomes more implicit and effortless, right? Like tying your shoes. The study even talks about that.
Exactly. First, you're following those instructions carefully.
Yeah.
But with practice.
It's second nature.
But here's where it gets even more interesting. The interaction between these two types of learning isn't always a clear-cut progression. This study highlights something called incidental learning.
Incidental learning. So what? My brain's learning even when I'm not trying to.
Exactly. Think about picking up a language by being immersed in a new culture.
Yeah.
You're not sitting there with grammar books all the time, are you?
No, definitely not.
But your brain is absorbing those patterns, the vocabulary, just through exposure.
Like I've totally learned some Spanish that way just from traveling.
See? Or think back to the bike riding. You weren't born knowing how to ride a bike, right?
Right. It just kind of happened, well, after a few scrapes and bruises.
And that's the really cool interplay between conscious and unconscious learning that this research dives into.
Speaking of diving in, how did they actually study this? The paper mentions something called a serial reaction time task, or SRTT for short.
Oh yeah, the SRTT. Think of it like this. There's a screen, right? And different colored squares light up. Your job is to press the matching key as quickly as possible.
Sounds kind of like a video game.
It is a bit. Now, some sequences are random, and others follow a hidden pattern.
Ah, so the researchers can see if you get faster at the pattern sequence, even if you don't realize you've learned it.
Exactly. Measure those reaction times. See if you're unconsciously picking up on the sequence.
Clever.
Yeah.
But wouldn't it be hard to know for sure if someone's really learning implicitly? Like, what if they kind of figure out the pattern but don't fully realize it?
It's a good point. It can be tricky to completely separate awareness from pure implicit learning in SRTT studies. This study tried to address that by including a separate explicit sequence. They actually told participants about that pattern and asked them to try to remember it.
Ah, okay, so that makes for a clearer comparison between the two types of learning.
Exactly.
Cool. So are we ready to move on to the brainwave part of this whole thing?
I think so. We've got those beta oscillations to explore.
Yeah, beta oscillations. But before we get there, let's back up for a sec. What are brainwaves in the first place?
Well, they're basically rhythmic electrical activity in your brain.
Okay, so like neurons firing together in a rhythm.
Yeah, like a symphony of neurons. And these rhythms, they happen at different frequencies, and each frequency is linked to different mental states.
Oh, interesting. So what are some examples?
Well, you've got delta waves, and they're linked to deep sleep.
Okay, so when I'm totally out, delta waves are having a party in my brain.
You got it. Then there are theta waves during drowsiness, maybe when you're meditating. Alpha waves happen when you're relaxed but awake.
So our brains are always humming along to a different tune depending on what we're doing.
A great way to think about it. And then there are the beta waves. They're most active when we're alert, focused, doing mental tasks.
So when I'm trying to learn a new guitar chord, my beta waves are firing away.
Yeah. Or when you're about to make a move in a soccer game. Beta waves are all about motor control, too.
Makes sense. But these beta waves, they're not just constant, are they?
No, they're not. They actually change in response to movement.
Oh, really? How so?
Right up before and during a movement, we see this dip in beta power. It's called event-related desynchronization, ERD for short. Then after the movement, there's a surge in beta power, and that's called event-related synchronization, or ERS.
It's like the brain is preparing for the action, then carrying it out, and then recovering, all reflected in these beta wave patterns.
It's a great analogy, and this brings us to the heart of the research. How do these beta waves behave differently during implicit versus explicit learning?
Right, that's the big question. What did this study find out about beta waves and our ability to learn new skills?
Well, the researchers had participants learn both an implicit and an explicit motor sequence over, I think it was 5 training sessions, and they were monitoring their brainwaves throughout.
5 sessions. Wow, they were dedicated.
They were, and the focus was on those beta oscillations in the motor cortex, the part of the brain that controls our movements.
Okay, makes sense. And drumroll, please. What did they find?
They found that both implicit and explicit learning led to an increase in beta power over those sessions. But here's the interesting part. Early in the training, the explicit learning group showed a much stronger suppression of those beta waves.
Now that's interesting. Why would explicit learning have a more dramatic dip in beta power at the start? What's the thinking on that?
Well, the researchers proposed that this initial strong beta suppression in explicit learning might be tied to, well, a state of motor readiness and anticipation.
Yeah.
You know, when you have that explicit knowledge of the sequence, like you know what's coming next.
Yeah.
You can anticipate it.
Oh, okay.
And they actually found a quote in the research that supports this.
Oh, yummy.
It says, beta oscillations are stronger when the current state is intended to be maintained. In turn, beta power suppression has been proposed to represent a state of motor or cognitive readiness related to perspective control and anticipatory mechanisms.
Okay, so break that down for me. It sounds like that dip in beta, that suppression, it could be a sign that my brain is getting ready.
It could be. It could be a sign of that motor readiness.
Like it's prepping for that next move.
Exactly. It seems like having that conscious awareness in the explicit knowledge, it allows for better prediction. And we might be seeing that reflected in these beta wave patterns.
Wow. It's amazing how these tiny brainwaves can tell us so much about how we learn.
It really is remarkable.
So does this tie into how well we learn and retain a new skill? I mean, is that connection there?
There might be. The study suggests a potential connection between how well our brains regulate those beta oscillations, how excitable our motor cortex is, and ultimately how well we learn and retain those motor skills.
Okay, so let's bring this all home for our listeners. Imagine someone's trying to learn a new skill. It could be anything, like playing an instrument, learning a new sport, or even mastering a new software program. What advice can we take from this research to learn better, more effectively?
Well, I think the study offers some really valuable takeaways. First, if you're aiming to learn something quickly, focusing on those conscious, explicit learning strategies might give you a real head start.
So really pay attention, break it down, try to understand the why behind everything.
Exactly. Engage that conscious mind. But here's the catch. Don't underestimate the power of consistent practice.
Oh, so that's where the implicit learning comes in.
Right.
Even if I'm not thinking about it super hard, my brain's still kind of working behind the scenes.
Exactly. The more you practice, the more those neural pathways get reinforced. So your movements become smoother, more automatic.
Practice makes perfect.
It really does. And it seems like practice also strengthens those beta oscillations. And that might even lead to better motor memory.
So the ideal way to learn is this kind of balance then.
Yeah.
Conscious effort and consistent practice.
I think so. You use that explicit learning to build a strong foundation. And then you let the implicit learning take over as you practice and refine that skill.
That makes a lot of sense. But before we wrap things up, there's one more thing that really caught my eye in this study. They found that some participants seem to be learning the implicit sequence explicitly. What's going on there? How is that even possible?
It's a great question. Even in that implicit condition, their brains were still being exposed to that sequence over and over again.
Huh.
It's possible that some people, maybe those who are really good at spotting patterns,
Yeah.
maybe their brains started to unconsciously pick up on the regularity.
So some of us might have a knack for that subconscious learning, like a hidden talent.
It could be. And that raises a really interesting question. Could we somehow hack that process. If we understood how some people learn implicitly so well, could we develop ways to boost that subconscious learning for everyone?
Wow. Now that would be amazing. Imagine being able to learn new things way faster by tapping into the power of our unconscious minds.
The possibilities are really exciting. Think about the impact it could have on education, rehab, skill development in any field. It really shows us how much we still don't know about what our brains can do.
Well, I have to say, you have totally changed the way I think about learning today. I'm going to be paying a lot more attention to those little cues and patterns I might be picking up without even realizing it.
And remember, don't forget about practice. Even when you're not breaking things down step by step, your brain is still hard at work making those connections stronger.
This has been such a fascinating deep dive. Thank you so much for walking us through all of the ins and outs of motor learning and those amazing beta waves.
It was my pleasure. The brain is truly a remarkable organ. And the more we understand how it works, the more we unlock our own potential, really.
And for our listeners, if you're eager to dig a little deeper into the science behind all of this, be sure to check out the show notes for a link to the original research. And as you go about your day, pay attention to how you learn new things. Whether it's a new recipe or a dance move, you might be surprised by just how much your brain is absorbing even when you're not consciously trying. Until next time, keep those brains buzzing.